All right, welcome to lecture 30. In this lecture, again, there's going to be three parts. The first one, we're going to talk about hydronium and hydroxide, how these two ions are super important to understand if you want to understand whether a solution is acidic or basic. So that's what we're going to get into in this one. And then ultimately the goal, we're going to finish up this lecture learning all about pH. So that'll be what the last two are all about, learning about pH. Okay, so let's go ahead and get started. So before we get into anything new, let me just remind you, in the last videos when we were talking about acids and bases, we talked about, well, especially if we base our ideas on the Arrhenius definition, that acids are things that make H plus, or we could say hydronium in water. Now, also, again, if we base our kind of ideas on the Arrhenius definition, Arrhenius said, hey, bases are things that make OH in water. Now, it turns out these two ions, the top one there, that's hydronium, and the bottom one's hydroxide. OH is hydroxide. Well, it turns out these two ions actually can form in just pure water. So if you have a cup of pure water, nothing at all in it, you actually will get these ions also present. Let me show you how that can happen. And the way it can basically happen is two water molecules can collide with each other, and one water molecule can give up one of its hydrogens to the other. So a hydrogen can get transferred from one water molecule to the other one. And when this happens, let's see what the products would be of this reaction. We would end up making, well, the first guy gained a hydrogen. So he's going to be not H2 anymore. He's going to be H3O. And that hydrogen also actually has a positive charge. So he would have become positively charged. Now, the second water molecule, the guy who gave up the hydrogen, he's not H2O, he's really going to be HO, right? But you might remember we like to reverse the order there. We typically write the part that's left after you lose the hydrogen, the second water molecule losing its hydrogen, it's going to be OH minus 1. All right, so this reaction happens. Again, it doesn't happen a ton. It happens a little bit in any cup of water. And when I say a little bit, I mean a real little bit. So typically in lab, like we might have like a 1 molar solution or a 2 molar solution. When this reaction happens, the amounts we make of these ions are extremely small. Like the amount of OH you get 0.00000, so 6 zeros and then a 1 molar. That's the concentration of OH that forms. Now, if I was to ask you how much hydronium forms, well, this reaction is balanced. So for every hydroxide I get, I also will make a hydronium, an H3O+. So from this same reaction, we also make hydronium, we make the same amount, 0.000, it's going to be 6 zeros, and then a 1 molar. So again, very, very tiny amounts. Like way less than when we kind of make up solutions, all right? Now, in fact, those amounts are so tiny that often when I write those amounts, because we're going to use these amounts pretty much in this whole lecture, we often like to put them in scientific notation. So if I was to write the amounts of hydronium and hydroxide you get from this reaction, you get, we could write it this way, 1 times 10 to the minus 7 molar will be the amount of hydronium you get, and yeah, you get the same amount of hydroxide. All right, so these guys form even in pure water. So typically we think of hydronium coming from acids, hydroxide coming from bases. That's totally true, but you also get them from just water reacting with itself. Now, this kind of leads us into kind of how these two ions relate to each other. And to help us understand that, I'm going to kind of write up maybe a little diagram to help us. So first off, pure water is neutral. It's not really acidic or basic. And when we talk about these ions, like I'm going to make kind of like a bar graph looking thing here. So this will be 0 on our bar graph. And when we have pure water, we get hydronium forming and we get hydroxide forming. Again, not much of each. So the amount, if I was to label this bar graph, these would go up to the 1 times 10 to the minus 7 line. That's how much you form. Like that would be the 1 times 10 to the minus 7 line. All right, so let me tell you a couple other things about pure water. All right, so and then we'll be able to compare to like what happens in an acid and a base. So in pure water, you have a concentration of hydronium that is equal to 1 times 10 to the minus 7 molar. And you have a concentration of hydroxide that is 1 times 10 to the minus 7 molar. And not only can I say that, I can also say, well, not only are they both equal to this tiny number, 1 times 10 to the minus 7 molar, they're also equal to each other. So the amount of hydronium and hydroxide, they'll be equal to each other. All right. Now, one other thing I should have mentioned, you notice that I'm using this bracket thing. Whenever you see a bracket means that we're talking about the molarity. So it's sort of a shorthand instead of writing M. If you put a compound, an ion in a bracket, it means the molarity of that thing. So the molarity of hydronium will equal the molarity of the hydroxide. All right, so in neutral, guys, these two ions are equal to each other. The amounts of them, the molarities of them are equal. Now, what about when you have something that's acidic or basic? How is that different? Well, let me flip over and we'll talk about that. All right, let's talk about when you have an acidic thing and a basic thing. All right, so if you have an acidic solution, remember what I said a minute ago? Acidic things, acids give you more hydronium. So when you have something that's acidic, what's going to happen? Maybe I'll start with those bar graphs again over here. When you have something that's acidic, this would be like 0 on our bar graph. The amount of hydronium actually will go up. So acids give you extra H3O+. So H3O+, now, again, I'm not really trying to do this exactly to scale, but if we imagine this is sort of the 1 times 10 to the minus 7 line, the amount of hydronium, because you have something that's acidic, it's gone up. Hydronium increases because of that acid that you put in the water or whatever. Now, what's not always so obvious, and I'm not going to really get into the reasons of why this, but what also happens when you add an acid into water is the amount of hydroxide actually falls. So the amount of OH actually goes down. So neither one of them is 10 to the minus 7 anymore. The concentrations have changed. Hydronium has gone up, hydroxide has gone down. All right, let's write a few facts about that. All right, I'll put my facts over here. So in something that's acidic, hydronium will be greater than 10 to the minus 7. Acids give you extra. They also affect the amount of OH. Hydroxide goes down. And then the amounts of these two ions, they're not in balance anymore. So when something's neutral, the amount of these ions is the same. Now they're out of balance. They're out of balance. So which way are they out of balance? Well, hydronium will be more than hydroxide. The amount of hydronium, the molarity of the hydronium will be more than the molarity of the hydroxide. All right, now what if you have something that's basic? Now remember, bases give you extra OH. They give you more, they give you extra hydroxide. So if I was to kind of do the same idea for basic, let's start off with our bar graph. Things are out of balance, but they're out of balance the other way. If we make this our 10 to the minus 7 line, OH grows when you have a base. OH goes up. Bases give you more OH than what you find in neutral water. And it also causes the amount of hydronium to shrink. Oop, little amount of hydronium to shrink. All right, so we're out of balance, but we're out of balance the other way. Hydroxide goes up, hydronium goes down from our normal amount. I guess when I say normal, I mean neutral, from the neutral amount, 10 to the minus 7 amount. All right, let's write a couple facts about those. So when something is basic, hydronium will go down from 10 to the minus 7. It'll shrink. Hydroxide goes up from 10 to the minus 7. And then the amount of these two guys, yeah, they're not equal, but now the way it works is hydroxide is greater than hydronium. All right. All right, now I think that's all I wanted to mention for this. Now, I do want to talk a little bit about, we've said, well, one goes up, one goes down. Like, can we do any better than that? Can we actually, like, calculate the amounts of these ions? Well, we can, and that's exactly what we're going to get into in the rest of this video. So if you know the concentration of one fella, hydronium, for example, you can find the concentration of the other fella, hydroxide, for example. And that is because no matter what kind of thing we're talking about, something that's neutral, something that's acidic, something that's basic, maybe I'll have to fit it up here because I didn't leave myself enough room at the bottom. Always the amount of hydronium times hydroxide, the concentration of those two ions, when you multiply them together, you always will get 1 times 10 to the minus 14. All right. So we're going to practice using this idea, that equation in the rest of this video. These two ions are related because they always together, when you multiply them together, you always get 1 times 10 to the minus 14. Now, I should mention that number, it does change based on temperature. In this video, in our book, in Sapling, we're going to be assuming you're at 25 degrees. I don't know, if you take a biology class or something, they might tell you that number actually, it would be different if you were at 30 degrees or 20 degrees. And then the only other thing I want to mention, if you're like, well, why do we care about these ions? Where's this going? Ultimately, understanding the amount of these ions, that's going to help us understand pH, which is kind of the last video we're going to get into. All right, so before we can talk about pH, we've got to talk about this just a little bit more. So let's flip over and let's practice using that equation you see up there in red just a little bit, make sure it makes sense. All right, a little example. All right, in a Coke, soda. I used to drink a lot of Coke, way too much Coke than I should have, bad for me. In a Coke, the concentration, the molarity of hydroxide is 2.00 times 10 to the minus 12. What is the concentration? What is the molarity of hydronium? So if you know one, you can always find the other one. So the way those two ions are related, let me write up that equation again. The amount of hydronium times the amount of hydroxide always make 10 to the minus 14. All right. So if I tell you one of them, you can tell me the other one. Now in this case, I'm telling you the amount of OH. So we'll go ahead and plug that in. And then we're going to solve for the amount of hydronium. All right. Now, little algebra. We'll have to do a little algebra. So to solve for the amount of hydronium, probably, I hope not too bad, right? What are we going to do there? We'll need to get hydronium by itself, H3O by itself. We'll take both sides and we'll divide by 2 times 10 to the minus 12. Now, when we do that, on the left-hand side, that 2 times 10 to the minus 12 cancels. So the amount of hydronium, well, it turns out to be this. All right, 1 times 10 to the minus 14 divided by 2 times 10 to the minus 12. All right, so we're going to have to get this into our calculator in a second. Let me just remind you how to enter this because we haven't done this in a while, right? These numbers are in scientific notation. So the way you're going to want to enter this on your calculator, most people, and hopefully you remember, everybody's calculator is a little bit different. the way you enter this, you would enter 1 EE minus 14, and then you're going to divide, and then the way you enter the bottom number would be 2 EE minus 12. All right. I'd highly encourage you to try it right now. Let me tell you what you should be coming up with. When you divide those two numbers, you should be getting, oh, I got to check my notes here. This should be what you get. You should get 0.005. 0.005. All right. And that would be the concentration of hydronium. All right. Okay. You could have an extra 0 on there for like sig figs and stuff, but I'll just say 0.005. Now, that looks right to me. Now, again, you might want to try it just to make sure. Okay. All right. So there is a second question on here, right? So we just figured out the amount of hydronium. That was this number right here. Now, based on what we've calculated, I want to know whether this thing is Coke acidic or basic, or it could be neutral, I suppose. So which one is it? Well, the way I'm going to know is, well, one way I can know is I can compare the amount of these two ions. Well, first off, if we look at them, is this thing neutral? No, it's not neutral. If it was neutral, the amounts would be equal, and they would be equal to 10 to the minus 7. So we're out of balance, right? We're out of balance. So we got to figure out which way we're out of balance. So maybe I should write down these numbers. I think I have enough room right here. We'll write down, let me, maybe I'll do it in a different color. We'll go with the red. Maybe, let's write down the amount of hydronium and the amount of hydroxide. And let's write them right next to each other. 2 times 10 to the minus 12. This number is 0.005. Now, they're definitely not equal. So you got to figure out which one's bigger. All right, which one's bigger? Now, that may not always be so easy in your head to figure out. Which one's bigger, 0.005 or 2 times 10 to the minus 12? One way you can know is you could take the number that's in scientific notation and you could take it out of scientific notation. That might make it a little easier to compare. So if I was instead to write 2 times 10 to the minus 12, if I was to write it as a normal number, it would be like 11 zeros, holy cow, and then a 2. I didn't really necessarily count 11 zeros. It would be like a bunch of zeros and then a 2. That might help you figure out which one's bigger. So the one that's bigger is the amount of hydronium. So hydronium is greater than hydroxide. If you got more H3O plus, you're acidic. All right, H3O plus is bigger than hydroxide. All right. With that, hopefully this makes sense. You know what? Let's try one. I'm going to put up another one here on the next page. Let's see if this makes sense. Let's see if you can try one. All right. Let me flip over and I'm going to give you a sec to try one. All right. Let me flip the page here. All right. Let's try one. All right. So you're going to get some pop-up questions on this. Let's see how it goes for you. In a solution, something sitting around your house, the concentration, the molarity of hydronium is 2.5 times 10 to the minus 2. What is the amount of OH? And is this solution acidic or basic? All right. Only hint I'll give you, and then I'm going to give you those questions to practice. Remember, hydronium times hydroxide makes 10 to the minus 14. You're going to need to use that. All right. So you'll get your 2 questions. Question 1, what's the amount of OH? Figure it out. Okay. What'd you come up with? All right. So you should have put in the amount of hydronium right here. You should be solving for OH. The way you would solve for OH, you divide by what? By 2.5 10 to the minus 2. Goodbye. When you divide by it, it's going to cancel out. You do it on the left, you got to do it on the right. So you come up with this. OH equals this number. Now you got to type this thing in your calculator. And oh, let me check my notes here. When you did it, you should have gotten 4.0 I'm going to write 4.0, like kind of keep track of my sig figs, I guess, times 10 to the minus 13. That's what you should have come up with. If you're worried about the sig figs, gosh, we haven't talked about those in a long time, have we? This number is like an exact number, so you can kind of ignore it for rounding. I started with 2 sig figs. I put 2 in my answer, 4.0 times 10 minus 13. All right, that's the first question. What is the amount of OH? Now, the second question, is this solution acidic or basic? Oh, did you get that one? Let's see. All right, the way we're going to figure that out is, first off, it ain't neutral because these two ions aren't equal. So we're out of balance. So maybe I'll put it right here. The amount of hydronium is 2.5 times 10 minus 2. The amount of hydroxide was 4.0 times 10 to the minus 13. So you got to figure out which one's a bigger number. Now, again, sometimes people get confused by these numbers because we got these exponents and they're negative. I mean, one solution to make sure you're thinking about it correctly, you could write them both as normal numbers. That might get a little easier to compare in your head. The other way you could compare these numbers to decide which one's bigger is the way it works when you have a negative exponent. The closer that number is to 0, the bigger that number is. So a 10 to the minus 2 is more than a 10 to the minus 13. So when you have negative exponents, 2 is bigger than 13. Negative 2 is bigger than negative 13. This guy on the left is actually the bigger value. All right, hopefully that makes sense. All right, so wait a minute. We're out of balance. Which way are we out of balance? We have more hydronium. If you have more hydronium than hydroxide, this thing is acidic. Should be acidic. All right. Hydronium is bigger than hydroxide. So I want to warn you because this is where you get confused often, where people get confused often. It's good to know that you're out of balance, but you got to make sure you're thinking about, well, which one is bigger, hydronium or hydroxide? So make sure you think about, okay, what does it mean if OH is bigger or hydronium is bigger? In this case, since hydronium is the bigger number, we're acidic. All right, one final example I want to show you on this one. One final example in this video. Let's flip over to it. All right, so the whole point of knowing the amounts of these ions, hydronium and hydroxide, the whole point of knowing the amounts is they have to do whether something's acidic or basic, right? They tell you whether you're acidic or basic. So let's say I tell you, you got some solution and the amount of OH is 1 times 10 to the minus 5. 1 times 10 to the minus 5. And I want to know, is this solution acidic or basic? Now you notice this time, I didn't ask you to calculate anything. I didn't ask you to calculate the amount of hydronium. All I want is to know whether, if you see that number, does that number go along with being an acidic thing or a basic thing? You can figure that out without doing any math. Now, how? Well, the way you could do it is you can compare the amount you have of OH to what you find in normal neutral water. So just to remind you, in neutral water, the amount of OH is 10 to the minus 7. In this solution, the amount of OH is 1 times 10 to the minus 5. So what number is bigger? Well, let's just compare to water. Do you have less OH than in water, or do you have more OH? Well, you actually have more OH. The amount, this number, oh my gosh, how can I write this? Maybe I'll just write it down here. This number is bigger than what you find in neutral water. All right. Now, if you have more OH than normal, what are you? OH is a lot of OH. That's what bases have. So this thing would be basic. All right. So if you have OH, extra OH, more than in neutral water, you're a basic solution. All right. So, the math is not, there's not a lot of steps or a lot of converting, but kind of knowing in your head, what do these numbers mean? That could be where people can get a little goofed up. All right. So hopefully this is making sense. With that, That's the end of this first video. We're going to move on, and in the next ones, we're going to talk about pH. That's what we're getting into. If any of this doesn't make sense, please let me know. I'll try to help you out the best I can. All right, that's it for part A.